All right, today's topic is linearity and continuity of graphs. So talking about how graphs look, how they're connected in certain ways, and then talking about linearity and how if a graph, when you plot points on a graph, do they form a line? Okay, that's really what we're talking about here. It's pretty simple to concept, okay? So first off, continuity. So what do we mean by that? We mean by our points on the graph connected, okay? So there's three different ways you could have it, right? If your graph is continuous, right, continuous, and hopefully you can read that. It means your points are all connected on the graph to form a line or a curve, okay? So very simple. If you see a graph and you have points that form a line, like such, right? It's just all, any point, excuse me, on your graph, it's all a line, right? This is a continuous graph, okay? Same as if you had it, and which makes sense, right? Because the line all continues, right? The lines all continue in a path. So continuous graph, just, points are connected. Okay. Yeah, I know. Points are connected, okay? So points are connected, right? So, and that also goes for a curve as well, okay? So it doesn't have to be just a line. It could also be a curve. So you could also have something like this. All right. You still have all the points on this graph are all connected in a curve, okay? So points are connected. That would be a continuous line. Continues one line, right? Pretty simple, okay? Another way you could have is if your line, if your graph is discrete. Okay, so if they're discrete, it just means the points are not connected. So you could have a points kind of anywhere, right? There's no rhyme or reason to them. They're just kind of there. All right, this would be a discrete graph, okay? So points not connected. All right, so that's pretty much it, right? So continuous, a line or a curve, discrete, right? Points not connected. It's just kind of random points on there, okay? And a third way you could see a graph setup would be neither, for lack of a better term, okay? Neither. Basically, this way, it's kind of a mix of both, right? So let's say you have a point and a line going up this way, all right, and then down here you have a point and a line coming this way, right? This would be neither. So you have some points that form a line or a curve, but they don't connect. It's not continuous everywhere, right? So we have two lines here, right? But they're not connected in the middle. They're just kind of doing their thing. But we do have some lines, right? So this is neither. So you have some points connected. Some points connected, right? So some points are connected on here, but not all of them, right? So that would be neither. So continuous, discrete, neither. That would be your three cases, okay, for coming to this. Another way you can see in neither would be you have something like this, where you have you kind of have like a line here, and maybe like a line here, and maybe like a point over here, right? Same thing. Some points are connected, right? You have a line, some connected lines here, but you have this point kind of hanging out over here, right? Neither. So it's both continuous and discrete. It's neither those two things specifically, right? It's kind of a mix of both, okay? So let's talk about linear versus nonlinear, all right? So linear versus nonlinear. So linear function, all right, a linear function just means that the function is a line, okay? The function has a line, right? So on a graph, obviously, it's any type of any type of line you have on a graph, right? That would be a linear function. It's a line, and hence line in linear, right? So just think of that. It's linear. It's a line. All right. Now, what do we know about lines? Well, remember that the equation of a line, right? Y equals mx plus b, right? That would be your equation of the line. So when you're trying to figure out if a line is linear or not, and you don't have a graph to look at it, you have to figure out, okay, so can I rewrite it in this way, right? Can I rewrite it in this y equals mx plus b form of a line? If that's the case, then yes, it's linear. Another way you could tell if it's a linear is if they have no variables with exponents. Okay, when simplified. That's it. That's the key part. I'll talk about this in a second. When simplified. Okay. So these are two ways you can figure out if a function is linear. You can rewrite it into this equation here, and that you have no variables with exponents when simplified. Okay. And I'll show you what that means in a second when I talk about. When I show you, I'll give you a little side-by-side chart to kind of make it a little easier to see. Okay, but that's basically the form of a linear function. Okay. So what happens if it's not linear? Okay. If it's not linear, right? Non-linear. Okay. A nonlinear line is a function that has points not on a line, right? So basically the opposite of linear, right? Pretty simple, right? Points that are where it's not on a line, okay? So when you have a nonlinear function, you cannot write it in mx plus b. So you can't write as y equals mx plus b. You can't have that, right, if it's nonlinear. And also with this one does have variables with exponents when simplified. Okay. So you can't. So if it's nonlinear. If you can't write it as y equals mx plus b, if it has variables with exponents when it's simplified, or if it has combined variables. Okay. So what do I mean by that? I mean if you have something like this where it's 4xy, right, where you have an x and a y in the same thing, okay, then this is also a nonlinear function. If it has anything like this where they're combined, it has to be separately. We have a y like this, right? It can't be like this. Let's do a side-by-side chart. I'll show you how that works out, okay? And maybe this will make a little more sense here. All right. So let's go linear. I'll just draw a little t-chart here. Linear, nonlinear, okay? So here are linear functions. Y equals 3x plus 4. 4x minus 3y equals 25. Y equals 4x squared minus 4x squared plus 3x minus 5. Okay? And then some nonlinear. Okay, so y equals x squared minus 4. 3x plus 4y third equals 23x. Y equals 1 over x minus 5. 2 minus 4y. Okay, so I'm going to show you how this works out. All right. Let's say, look at the linear side here. Okay. So we have mx plus b, right? Y equals mx plus b. M is your slope, remember, right? So it's in this form. It's linear. Here you have 1x and 1y, right? There's no exponents. It's 1x, 1y number. You can rewrite this as here, okay? But the simple thing, if you just don't want to rewrite it, is to say, okay, hey, look, it has 1x and 1y, right? That's what we're looking for here. And then here, yes, we do have exponents, okay? And I know I said that it can't have exponents, but when it's simplified, if you were to go ahead, you see how they're both, it's 4x squared minus 4x squared. Well, what happens with these two things, right? They cancel out. So they cancel out. You can rewrite this as y equals 3x plus 5 because these cancel out. Okay, when you simplify it. Okay, so that's why this one works, because you can simplify, you can subtract these, cancel them out, and then all you're left with is 3x minus 5. Okay. Nonlinear. First thing right here, we have x squared. Okay, x squared. Like I said, you can't have an exponent in here. This is all simplified, right? It's not like this one. This one is simplified. You can't have it here. Nonlinear. Same thing here. You have y to the third. You have two x's going on here, right? Nonlinear. It needs one x and one y. One x, one y. One y, one x, right? That's what we're looking for. Here, okay, and I'll kind of circle these here. You can't have that. You can't have that. All right, here, check this out. This x is on the bottom, okay, of this fraction here. It's the denominator. You can't have that, okay? You can't have your x here. And then down here, right, we have an x and a y. If we were to distribute these and simplify like this and do x times 2 is 2x and x times here is negative 4xy, right? Now we have this part here that's xy, and that's why this does not work, okay? So this is what happens, difference between a linear and nonlinear, okay?